So in section 15.1, using graphs and properties to solve equations with exponents, we have to start off with a little bit of a precursor lesson. If you're in my intervention class, we did this a little bit earlier in the year, and that was prime numbers. So a prime number is a whole number greater than 1 whose only factors are 1 in itself. And I'm going to give you some examples. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, and there's like literally an infinite number. But basically, hopefully you can tell that 2, 3, and 5 are only divisible by 1 in themselves, but 4, right? 4 is divisible by 2, right? You can divide 4 by 2. And you can divide 8 by 2. And you can divide 9 by 3. So you'll see, like, that's why these are not prime. You could divide 10 by 5 or 2. Right? So that's why 10 is not prime. And so basically any number like 12 that's divisible by some other number, right? You can divide 12 by 3, by 4, by 6, by 2. Since that's the case, 12 is also not prime. And you're like, so what? Why do I even care? And, that might be a good point, except for by actually knowing what is prime, there's an interesting property about whole numbers. And whole numbers are basically, whole numbers are the numbers that go from like 1, 2, 3, 4, ... forever. Any whole number is a product of primes. A product of prime numbers. That means either it is prime, as in the case with 2, 3, 5, 7, 11, 13, 17, and so on, or it's the result of two prime numbers multiplied together. And so now that you have this little intro on prime numbers, that'll make the rest of this a lot easier to understand. So let's begin with this notes part. Two powers with the same positive base other than 1 are equal if and only if the exponents are equal. Algebraically, if b is greater than 0 and b is not equal to 1, then b of x is equal to b of y if and only if x equals y. And I'll tell you why that's significant. If I have 2 to the x is equal to 8, for example, in this scenario, 2 is my base. And how do I figure out x? Well, 8 technically is 2 to the third power. So if 2 to the x is equal to 2 to the third, then x must equal 3. And so that's an example. You'll see some more here in a second. Let's take a problem like this. It's 7 times 3 to the x. So the first step we're going to do in algebra is the opposite of multiplication, which is division. So you're going to get 3x now is equal to 9. And now we're going to take this number 9 and we're going to look for its prime factors. So 9 is equal to 3 times 3. In other words, 9 is 3 squared. So 3 to the x is equal to 3 squared. and that makes x equal to 2. So let's do this other example, right? If it's times 2/5, you're going to have to divide by 2/5, which makes 5 to the x equal to 625. And you're like, well, holy smokes. I could tell 9 was 3 squared, but I have no idea what 625 is, what power of 5 that is equal to. Well, let me help you out here. We're going to try to break it down into its prime factors. So I know 5 is prime, and if something ends in a 5 or ends in a 0, it's divisible by 5. So 625 divided by 5. This is something you can punch in your calculator. That's 125. 5 times 125. You're not quite done. Again, if it ends in a 5 or a 0, it's divisible by 5. So divide 125 by 5, and you get 25. And then 25 is 5 times 5. This is like a factor tree, if you will. We actually did this in intervention class for a couple weeks. And it's going to pay off, at least I hope, right now. So 625 is literally the product of 4 5s. 5 times 5 times 5 times 5. In other words, 5 to the 4th power. So 5 to the x, let me rewrite that. 5 to the x is equal to 5 to the 4th. And these two are only equal if and only if x is equal to 4. So there's this example. Let's do a couple more. So if this is multiplied by 1/4, I have to divide by 1/4. If I divide by 1/4, that's the same as multiplying by 4, but in any event, your calculator will do this. So you get 5/6 to the x is equal to, this simplifies to 25 over 36. And 25 over 36 is really 5 squared over 6 squared, which is really 5/6 squared. So 5/6 to the x is equal to 5/6 squared, which makes x equal to 2. So hopefully that's making some sense. If it's times 2, I have to divide by 2. If I divide by 2, that's the same as multiplying by 1/2. So 250 divided by 27 divided by 2. You're going to get 5/3 to the x power is equal to 125 over 27. So now we have to ask ourselves, we have to break this 125. Right, 125 is divisible by 5. I think it's 5 and 25. And then that's divisible by 5 and 5. As a product of primes, 125 is equal to 5 to the 3rd. 27 divisible by 3 and 9. And 9 is divisible by 3 and 3. So as a product of primes, it's 3 to the 3rd. So basically what you have is 5 to the 3rd over 3 to the 3rd, which is the same as 5/3 to the 3rd. So x is equal to 3 in this scenario.